The fastest way to make a RAG system look smart is sometimes to stop trusting your best retriever.
Exactly. Reciprocal rank fusion, or RRF, is a simple way to combine multiple ranked retrieval lists, so one shaky search method does not control the answer.
So, this is not another fancy re-ranker. It is more like a referee between search results.
That is a good way to think about it. You run different retrieval methods, like keyword search and vector search. Then RRF merges their rankings into one better shortlist.
Why should a programmer care? If one method is already decent, why add another moving part?
Because decent is not stable. In production, queries shift. Some users type exact error codes. Others ask vague conceptual questions. One retriever wins one moment and loses the next.
Give me a concrete case.
Say your docs include an API page with the exact string ERR off Z14. BM25 or keyword search will likely nail that. A vector retriever might miss it because the code itself carries little semantic meaning. Now flip it. A user asks, how do I stop login failures after token rotation? Vector search may surface the right guide, even if the wording does not match exactly.
So hybrid retrieval exists because different search methods have different blind spots.
Right. Hybrid retrieval usually means you combine lexical retrieval, which is great at exact terms, with semantic retrieval, which is great at meaning and paraphrase. RRF is one of the easiest ways to combine them.
What does RRF actually do in plain English?
It rewards documents that appear high in multiple result lists. If a document shows up near the top from more than one retriever, RRF boosts it. If it appears in only one list, it still gets credit, but less confidence.
So the system is asking, what keeps showing up when different retrieval styles take a shot?
Yes, it treats agreement as signal. Not perfect truth, but useful signal. That matters in RAG because the generator only looks smart if retrieval hands it the right evidence.
And if retrieval misses, the model starts improvising. That is where trust dies.
Exactly. Bad ranking is not a small quality issue. It changes who wins. The doc that lands in the top few slots gets read by the model. The others might as well not exist.
Walk me through another example where combining rankings beats picking a single champion.
Imagine an internal support bot for a payments team. A developer asks, why did webhook signature validation fail after we moved to the new gateway? Keyword search catches docs with webhook signature validation. Vector search catches migration notes that talk about changed signing secrets and header format. Separately, each retriever returns part of the story. With RRF, documents that are relevant from both angles rise together.
That sounds less like averaging and more like assembling a stronger case.
That is the practical win. Combining rankings helps because relevance is messy. One retriever might be sensitive to exact nouns, another to intent, another to metadata filters. When multiple signals independently point to the same document, you reduce the odds of a single bad miss.
And this avoids a common trap, right? Trying to compare raw scores from different retrievers.
Yes, that is one reason developers like RRF. BM25 scores and vector similarity scores do not naturally live on the same scale. RRF mostly ignores the raw numbers and focuses on rank positions, which makes fusion much simpler.
So instead of arguing about score calibration, you ask, who placed this doc near the top?
Exactly. It is robust, easy to implement, and usually a strong baseline. You can get meaningful gains without building a custom learning-to-rank system.
Where does it matter most in a RAG stack? Search quality? Latency? Failure modes?
Mostly search quality and failure control. RRF will not fix terrible chunking or bad source content, but it can reduce brittle behavior across query types. That means fewer embarrassing misses, fewer wrong citations, and a better top K set for re-ranking or generation.
Give me one implementation pattern a programmer could actually use this week.
Run BM25 and dense vector search in parallel for the same query. Take the top 20 from each. Apply RRF to produce one merged top 10. Then, if you want, send that smaller set into a cross-encoder re-ranker before handing the final context to the LLM.
So RRF is not the last step. It is the practical middle layer that keeps weak retrieval from poisoning everything downstream.
That is the key insight. In hybrid retrieval, RRF turns disagreement into resilience. It lets exact match and semantic search cover for each other instead of competing.
And the strategic consequence is brutal. If your retrieval stack cannot merge signals well, the wrong chunks keep winning.
Right. Reciprocal rank fusion is simple, but the payoff is huge. When rankings collaborate, your RAG system stops guessing which search was right and starts betting on evidence that survived more than one test.